In this video, we're going to discuss OpenAI Whisper, which is a tool that can let you translate your audio and video files that have English discussion or dictation or anything like that, and it can help you translate those into text files. It also supports some other file formats, which we will discuss later in this video. It also supports transcribing to not only plain text files, but also to some other special formats, which could be useful for somebody, let's say, that wants to be able to look at a text file and search for like when they said something in the file, and then see what time did that happen in the original audio or video file. This video includes several OpenAI Whisper tutorials. All of them are kind of somewhat similar or the same, except one of them, for example, is a very simple way to use an OpenAI Whisper on Windows. I'm guessing most Windows users will probably want to just focus on that one section of this video. The other sections focus on Linux. There's one Linux tutorial that is comparable to the Windows tutorial. Both of those tutorials cover the very simple way to get going with OpenAI Whisper on Windows or Linux. If you're a Windows user, you might want to focus on that Windows tutorial. If you're a Linux user, you probably want to focus on that easy install setup Linux tutorial. And finally, there are two other tutorials which are geared toward AMD GPU users. Now, whether those tutorials are applicable to you or not is going to depend on, the GPU you have and whether or not it's compatible with ROCm, ROCm, which is an API technology stack from AMD, which allows software to access the GPU for acceleration, similar to the way CUDA does, but this is offered by AMD. Now, I happen to have an AMD GPU in one of my systems, so I was curious about using ROCm with Pytorch, which OpenAI Whisper uses. So OpenAI Whisper is built on top of AI technologies such as Pytorch. And Pytorch can use your CPU, but it can also make use of GPU resources if you have a build and a setup and hardware that's compatible with Pytorch for GPU acceleration. AMD just happens to have some ROCm technologies that work with Pytorch to access their GPUs for acceleration. So on compatible AMD hardware, you can use OpenAI Whisper with the right ROCm stack to access GPU acceleration. We're going to cover two ways in which you can use the AMD GPU with ROCm and Pytorch and OpenAI Whisper. One way uses Docker containers. If you like Docker containers, it's kind of a nifty way to go about and approach things. So you might like that tutorial. And finally, we have just a plain old native Ubuntu install where we install ROCm natively, we install Pytorch natively, and OpenAI Whisper natively. That means like not in a container or anything like that, just directly on the system. Hey folks, and since recording that introduction, I ended up using a laptop that I have, which has an integrated NVIDIA GPU, to create a tutorial to install Pytorch for CUDA for that particular system. As part of both the AMD and the NVIDIA walkthroughs in this tutorial, we have sections that perform a transcription of a 1-minute clip with GPU acceleration. And on those same systems, we perform a transcription of the same clip, but without any GPU acceleration, just using the CPUs on those respective systems. Now, those performance tests are meant merely to compare CPU versus GPU acceleration on those respective systems, and they're not meant as comparative tests between those two technology companies. And the reason why that's important to call out is the NVIDIA system with the integrated GPU is a 7-year-old laptop, approximately 7 years old, whereas the AMD system is using, a W6800 Pro Graphics GPU on a relatively new and powerful desktop. It's really not an apples to apples comparison of the two different technology company offerings. That's not what the goal is. The goal is merely to show the advantages of installing Pytorch with GPU acceleration for the platform that you happen to be using. Just keep that in mind. So again, if you're a Windows user, just focus on that simple Windows setup tutorial. If you're an Ubuntu user and you don't want to worry about GPU acceleration or anything, and you may not need it depending on how many audio files you have and how much of a performance benefit there is. And that's something you can find out as you work with OpenAI Whisper. Because if you do the simplest installation and you're happy with the transcription speed, then you really don't need to worry about anything else. If it's working, don't fix it. Just use the simple installation. But if you have an AMD GPU and it's compatible with ROCm and Pytorch, you might want to look at those more advanced tutorials. All these tutorials are accessible via the table of contents, so you can just simply click which item on the table of contents you want to look at. The first one is the Windows setup tutorial, since I figure most users might want to look at that. And if you're an advanced user, you'd be more apt to click on the table of contents to pick and choose which one you want to see. So pretty much all the Linux stuff is stuff that'll be later in the video where you can click the table of contents. And for those of you that just want to see the whole thing or jump around, hey, go for it. With all that said, let's get into it. In this video, we're going to transcribe clips as part of the demonstration. That's going to happen several times. Therefore, I have 3 different clips that we're going to use for the transcription demonstrations. These clips are very brief, and I'd like to play them up front so that you can hear them. And that'll help set your expectations for what we should be expecting as part of each transcription demonstration. All right, let's listen to each of these clips. So here is clip number 1. Hello, this is clip number 1, testing 1, 2, 3, 4, 5, 6, 7, 8, 9. This is clip number 1. I'm testing clip number 1. Testing 1, 2, 3, 4, 5, 6, clip number 1. All right, that's clip number 1. All right, here's clip number 2. This is clip number 2, ABC 1, 2, 3. I'm now going to pause for about 5 seconds and make noise. Nonsensical noise in here. I don't know if it'll pick that up as nonsensical. Now we're back to normal speaking. ABC 1, 2, 3. How are you? This is clip number 2. All right, that's clip number 2. And this is clip number 3. This is clip number 3. Hello, 1, 2, 3, clip number 3. 1, 2, 3, clip number 3. This is clip number 3. You've been listening to clip number 3. ABC 1, 2, 3, clip number 3. Okay, that's clip number 3. And then we have one additional clip. I call this the long clip. It's a 1-minute long clip, and I mostly use it with the performance tests when comparing CPU versus GPU transcription. So here is clip number 4, the long clip. We're going to make a long clip here. 1, 2, 3, 4, 5, 6. When the sun shines, it's bright and it's warm. When the moon shines, it's not really shining, but reflecting. When the moon shines, it's usually cool out. The quick brown fox did something, jumped over the fence, but I don't remember the rest. I'm continuing speaking during a long clip. This clip should be about 1 minute long. A, B, C, D, E, F. 1, 2, 3, 4, 5, 6. 10, 9, 8, 7, 6. This is a long clip. This is a long clip. Dogs and cats can get along. Dogs, cats, mice can get along. It doesn't always happen, but it could. This is the end of a long clip. I'm going to end this clip after I count down. 5, 4, 3, 2, 1. End of long clip. That was clip number 4. All right, let's go on to the next section. All right, now we're on Windows 11. Let's start by downloading Python and installing it. So we're going to go download. All right, we're going to click download to download. I'm going to click save, and we're going to run it. I'm going to click to add Python to the path. Now I'm doing that for simplicity here. If you have some other way of locating it once you install it, that's fine. I'm going to click install now. Great, Python is installed. We're going to click close, and we'll see if Python's on the path. It should be because I selected to put it on the path. So just with Python installed, without using Miniconda or anything like that, the simplest way to get OpenAI Whisper up and running is not to worry about any kind of GPU acceleration. Just go ahead and install the OpenAI Whisper package, and it will use whatever is available. So if GPU is not available, it'll at least use CPU, but if it has access to some kind of hardware acceleration, it'll go ahead and use that. Okay, OpenAI Whisper requires ffmpeg, and it should be on the path. I'm going to get mine from the Microsoft package repository, so I'm going to use winget install and ffmpeg essentials build, as you see here. Okay, it's installed. Now, if I type in ffmpeg right away and version, so you can see it doesn't find it right away, and that's because we need to reopen this terminal window. So I'm going to do that now. So we'll click close, and I'm going to reopen. And with the new terminal window open, I'm going to type in ffmpeg version, and we see that it can find it now. Okay, with ffmpeg installed, we can clear the terminal window, and we can go ahead and let's create a Python environment here. And I'll call this Py-Whisper. And creating a little environment like this is just a way of creating a separate area where we can install some things. And that way it won't install things in the global environment. So we can just delete this environment later or something like that, and all the changes we make will be in there, and it won't mess with the global settings for the system. So it's very common to create environments like this. Once the environment's created, it'll create a subdirectory as you see here, and in there'll be scripts. This is on Windows, so there'll be a scripts folder. It differs on Linux. There's going to be like a bin folder. So here I'm just going to hit enter, and you can see it changed to this new environment here. And now we can just type in pip install OpenAI-Whisper. And it's going to go and get the latest package. Okay, great, it's installed. I'm going to clear the terminal window and going to type in Whisper, and we can say version. And you can see it outputs probably the version up here. Well, it doesn't output the version, but it has the usage string, so we know it's installed. Oh, here, it actually doesn't understand that argument, so we just type in Whisper help. There we go. Either way, we see that it's installed and running. So in this folder, I have a directory called test audio clips, and that has all the test audio clips. So let's actually transcribe just the first audio clip, test audio clip 1.mp4. It's kind of a short clip. So this is going to run the Whisper command, and it's specifying that the media file has English to transcribe. However, if you don't specify English, it's going to try to figure out what the language is. And that actually takes more time. So typically, if you know what the language is, you probably want to specify it, so that way it'll work faster. So we specify language of English, and then we specify test audio clip 1, and we hit enter. And you can see that it has transcribed the file. And if we do an ls test audio clip 1 and then star, we can see that it output all of these files. Now these are just different formats of the same transcription. So for example, if I actually cat the text file here, you can actually see that it's just plain old text file. If we look at this SRT file, now these are kind of helpful because they have the time at which different portions were transcribed. So you can kind of know, like, this happened at 15 seconds into the media clip. And that's really the simplest way to begin using Whisper. Okay, for this next test, we have a folder right underneath demo called Test Audio Clips Multi-Directory. So this folder just has a couple of subfolders. Each one has a media clip. So we can look in these different ones. Here's one that's 2 levels, and it has an MP4. And our goal is to transcribe any media files within this subfolder. Now we're on Windows, so I'm going to use PowerShell. So here's a small PowerShell program. It accepts as a parameter a root path. That root path is going to be this multi-directory folder here. And it's then going to get all of the files in there which match these extensions here. This is just arbitrary choice of a few different media file extensions. Right now there's only MP4 files in that folder, but there could be other files as well too. And then for each of those files, it's basically going to output the command that it's about to run, and then it's going to actually run that command. And the command is going to specify that the speech within the files is English. We're only going to output one of the formats, which is the SRT format, just to avoid cluttering with lots of different formats. The folder for Whisper's output is going to be the same folder that the file is within. And then finally, we specify the media file itself. All right, let's give this a run. Okay, here's the script being referenced. Then we have the root path. Let's press enter. And it's going and it's running this now. And while it's running this, we can actually go over here, like in folder 1. We can actually look around in here just to see if it's done any work. Oh, here, it's done this one here. And it's finished this one here. So it's going to do these first. And I would guess that it's just going to go in here after. And here's this one. So let's load in one of these. Let's load this into VS Code. And there's a time value here which lets us know just generally where these words that were transcribed occurred within the media file, in this case the MP4. And we go over here and it's finished, and there you go. Okay, on Linux you want to make sure you have Python, and here I have Python 3.10 installed. And then I'm going to run pip install OpenAI-Whisper, as you see. And after installation, we can verify by, let's say, typing help here, whisper --help, and we can see it's installed. And I have test audio clips in this folder called test audio clips, and these are all kind of short clips. So let's transcribe clip number 1 as an example. So we're going to transcribe it by running the whisper command. We're going to say that English is the language. Now, if you don't do this, it will work to auto detect it, which could take an additional 30 seconds. So if you know the language, it can be helpful just to specify it here, save a little bit of time. We're going to use the small model. Now, the small model sounds like it's small or insignificant or something, but it actually works quite well. Let's go ahead and hit enter and run this. Now you can see when we ran this command the first time, it actually had to download that model. After it downloaded that model, it then began the transcription process, and you can see that it worked quite well. Now, if we run the same command again, you'll notice it doesn't have to download the model, so it goes faster. And you can see that was a little bit faster. It didn't have to download the model. Okay, let's try another test. This test we're going to try is going to have this folder here called Test Audio Clips Multi-Directory. And that's basically a root directory that has within it a bunch of subdirectories. Each one has an audio clip or a video clip that contains audio that we wish to transcribe. Over here we have a script. This is run whisper native. So this other one here is the one that works with Docker. So right now we're focused on this one that's going to run whisper locally. And basically it accepts a single parameter to the root directory. And within that root directory, it's going to search for any files that have these extensions. And for any files that it finds, it's going to go down here and it's going to run the whisper command to transcribe the file, and it's going to output the transcription side by side next to the actual input audio or media file. Notice I have -f srt. That's going to instruct Whisper to output only an SRT file. That's the file that has the transcription along with the timestamps. There's a number of formats that it outputs, but in cases where you don't want every single format each time you do a transcription, it's just nice to specify what it is you do want, and then you don't create a bunch of extra files. So with all this set up, we can go over here to the terminal window, and we're going to run the script here against all those files in the multi-directory. Let's hit enter and see what happens. So you can see it's going to go through and it's going to find all these audio clips and it's going to transcribe them. So you can see it's already finished with this first one in folder 1. So we can go over here and look at folder 1, and you can see here's the SRT file which contains the transcription. If we open this in a text editor, you can see here's the transcription. If we go back up here, we can see it's actually finishing all these. It's on this last one, it seems like, and there, it just finished the last one. So if we go back over here, we can see that this finished. So you can see how easy it is to create a script that can call OpenAI Whisper on an entire subtree of files that you might have. So I'm going to show an approach which uses Docker and one which installs directly. So since I'm going to show both approaches, I'm going to install Docker. You don't have to install Docker if you're not going to use that Docker approach. All right, let's search for Docker Ubuntu. Here we go. Install Docker Engine on Ubuntu. And there's a couple different ways of doing this. I've done both before, but I'm going to try doing it this first way here, which first one is they have this to remove any existing packages which may not be compatible. So we removed all conflicting packages. I didn't see anything conflicting, but I always just follow that part of the instructions and set up the apt repository. So let's just paste this right on in here. And I'm not necessarily recommending that you set this up this way. You might want to use one of the other methods. For this particular system, I don't mind adding this to the apt repositories and using it that way. For me, it's just simpler here. So now we're going to install the latest version. So I'm just going to copy paste this. And there it goes. All right, great. So that's installed. All right, with Docker installed, I'm going to type in Docker, let's say image ls. Okay, so we have this permission issue. Let's add a Docker group. This may already be added, and it already exists. Okay, great. Okay, let's add this current user to that group. All right, great. The user's added. So if you want to, you can go ahead and reboot. Okay, I've rebooted. Now let me see if we can just run this command. Okay, we can run this command. Now let's do a quick test to see if we can run a Docker test container. So we'll use the hello world image. I'm going to say Docker run hello world, and it's it's going to go and get that image and run it, and it's already done even before I could finish saying that. Okay, so now that we've run the Docker hello world image at least once, we can say Docker image ls, and we can see that the image is downloaded and it's present there in the local repository. So if we type in Docker container ls, we don't see anything there because there are no containers that are currently running. If we add -a, it'll show us all containers, including those that are currently stopped. We can see that the one hello world container that we ran is stopped. Okay, let's go to the AMD ROCm Docker website here. And there should be a top result here that says install Docker containers right here. Now I go down to the bottom here and just make sure I'm on the latest documentation. I'm on the latest 602 documentation. Your version may differ if you look at this at a later time. And they have a bunch of information in here about how to run these Docker containers that they pre-create. And they pre-create one that has ROCm and Pytorch ready to go. So we want to look for that. Now, I know a shortcut to that, but let's just scroll down the page here and see how you can come here and infer that for yourself. So the initial documentation is going to tell you things about the parameters that are going to be used to run the container. I'm just going to use those, and you can come back here and read this if you want to. So let's go down here on the page, and we see here, if we go down here to the bottom, you can see here there's base images here down at the bottom of that page. And if we go to Docker Hub here, let's do cookie settings, and we don't want functional, we don't want performance, and we don't want targeting, and I'll confirm my choices. Of course, this is just completely helpful. And now we're going to scroll down here and we're going to look for the one that has Pytorch. Here's the one that has Pytorch right here. And they even give you a way to pull the container here. If you just click on that, you'll copy the command. Let's just copy that. Let's go back to the terminal window. I'm going to clear this and then I'm going to paste in that command and we're going to hit enter. Now, it doesn't have the image initially, so it's going to take time to pull that image down from the Docker Hub. All right, there we go. The image has been downloaded. Now we should be able to, let's clear the terminal window here and let's do a Docker image ls, and we can see it's there. Okay, I'm going to go back here to the install ROCm Docker containers on the AMD website. And over here on the left pane, there's an install Pytorch link. I'm going to click on that link. And if I scroll down, they're going to have some examples on how to invoke the container. So if I grab this here by just clicking on the copy button up here, and now I can go over to the terminal window and paste this in and hit enter. And we can see it runs the container. Now the container, if it had not been downloaded at this point in time, it would have done the download. So instead of doing that pull, you can actually just run this and it will do the pull and then it will run. What we did is we did it in two steps. We did the pull first because I wanted to show you Docker Hub. Then we went back to the AMD website and we're doing the Docker run. Now you can read about these options. A lot of these options are recommended and specified on the website there, on the AMD website. You can read about those. We're not going to focus on those for this particular tutorial. All right, so right now we're in a running container, and what we can do is set this up to run OpenAI Whisper. But before we do that, let's type in ROC and hit the tab key twice. And you'll notice there's some ROCm commands there. Let's try typing rocminfo and hit enter. And we're not going to go over this in detail, but you can see it outputs information about the hardware and some of the ROCm setup information and configuration information. So OpenAI Whisper needs ffmpeg. So let's go ahead and do an apt install ffmpeg, and I'm going to say yes. And there we go, that's installed. Okay, I'm going to go ahead and install OpenAI Whisper with pip install OpenAI Whisper. Beautiful, it's installed. Now let's perform a quick test to make sure that ROCm is installed correctly and that Pytorch is using the GPU. And we'll do that by pasting in this small little Python program on the command line. We'll hit enter and it will return true if it's using the GPU or if Pytorch can access the GPU. We see that there's true here, so it looks like we're good. Okay, so the next thing that I want to do here is just run Whisper and do a help, and we'll just see that it's running. Okay, great, it's running. All right, now I'm going to exit this container, and we're going to hit exit. And what that's done is it stopped the container. If we say docker container ls, we see that there's no containers running. If I add a -a onto that, we're going to see not only do we have the hello world container that we ran a while ago and it's no longer running, but we can see here's a container that we created and ran based off of the ROCm Pytorch image. That's the one that we just exited. And you can see that we created that about 4 minutes ago and we exited about 13 seconds ago. All right, so if we have Docker container ls-a and we see this container that we once ran, how can we start this container back up again? Well, we can type in Docker container start and -a for attach, -i for interactive. We can then copy and paste the hash here for the container and we can press enter and the container will start up. We can verify that by typing in Whisper, and if it's there, that's the container that we had set up before. Okay, we're actually going to type in exit and we're going to clear. Okay, now we're going to rerun the same image and create a new container, but we're going to do something a little bit different. I am going to go to the demo folder. That's where all the test audio files and everything like that are located. So here's our test audio clips. So they're in this demo test audio clips folder. So what we're going to do is I'm going to copy that to the clipboard. Then I'm going to recall or enter in the same Docker command, but I'm going to modify it before I hit enter. I'm going to go to the end of the command line here and I'm going to type in a -v and I'm going to then paste in that folder and I'm going to put a colon and then I'm going to put / and shared. Then I'm going to put a space and then the rest of the line is going to have the image name. So what this -v, this is the volume switch, and what we're saying is the local folder on our local system here, the native folder where these audio clips are located, those are actually going to appear within the container in a folder named /shared. So basically -v in some sense is a way for us to share a host or native folder with the container. So we're going to hit enter. And after we hit enter, we see that the container has started, and I'm going to type in ls/shared. And we can see that the same audio clips are present while we're within the container. Now, this is a new container, so if I type in Whisper help, it's not even installed. So let's reinstall everything again. Okay, so let's set everything up again. We're just going to paste in the same command. So we're going to install ffmpeg. I'm going to say yes. After ffmpeg, we're going to install OpenAI Whisper with pip install OpenAI Whisper. Great, OpenAI Whisper is installed. Let's actually paste in a command just to verify that the GPU is accessible to Pytorch. And we see there's a true, so it is. All things look good. Now I'm going to do an ls shared again so we can see that there are the 3 audio clips, and I'm going to paste in an OpenAI Whisper command line here, and this OpenAI Whisper command line is going to specify the language as English, the model is going to be the small model, and the output folder is going to be /shared, and the input file that it's going to decode is going to be the test audio clip number 1.mp4. Now the language English, we don't have to specify that, but OpenAI Whisper can take up to like 30 seconds to figure out what the language is. And so when we tell it what the language is up front, it's sort of an optimization, right? It doesn't have to go through that step. It'll just move forward as though the media file contains English verbiage to transcribe. And the small model sounds like maybe it's simple or deficient or something, but I find it's actually quite powerful, just that small model there. So if you have files, you'd probably have to test with the different models and see which one you like, and you'll just have to figure out what's right for you. But for our demonstration purposes, using the small models just fine. So I'm going to hit enter here, and we can see that it's downloading the small model right now. It only needs to download the model on the first use. And there we go. We see that it has translated. It's output the translation there so we can see it. And let's actually do an ls on the shared folder. And we can see, in fact, let me just do an LA on this so that we can see the details. And you can see here's test clip 1. And you can see all the transcription outputs that were created along with running this command. So for example, if we look at the shared test audio clip 1.txt, we can see that it's just a text file. If we look at the SRT file, we can see that this includes the time markers where different transcriptions occurred. Now, the main thing I wanted to show you here is we're going to exit out of this container. So I'm going to type in exit. And after I exit, let's actually look at what's in the local folder. We're now looking at the native local Ubuntu folder here. And if I do an ls-la, you can actually see the same files exist here. So what you see here is that the container in relative isolation did some work, but it worked off of data that we had in this shared folder, and its results were put into that shared folder as well. Okay, I'm going to clear the terminal window. And the next thing I want to do is type in Docker and container and ls. And we can see that there are no containers running. Let's add the -a for all. And we can now see that there's 2 Pytorch containers, one that we created a long time ago and the one that we just created just now. Now, the one that we created just now is one which actually has that small model already installed, and it has already performed at least one transcription. So what I'd like to do is save that container as an image so that we can run that image and it will be ready to go with the small model already downloaded and with AI Whisper and everything already set up. So the way we do that is we're going to type in docker commit, and we know that this container was the one that was created most recently. So this is the one that we were just running, and so I'm going to grab this container ID and paste it in here. Now let's give a name to this new image. I'm going to call it our Whisper and hit enter. Okay, the new image has been created, so I'm going to type in docker image ls. And we can see here is the plain Jane original base image that comes from Docker Hub, which AMD has created for us, and they've posted it to Docker Hub. We ran that image and installed it and prepped it by running through a transcription. And then we created our own image that has OpenAI Whisper already installed, and it already has that small model already downloaded to it. So now instead of running the plain Jane PyTorch image and performing an OpenAI Whisper install every time and downloading the models every time, we can actually run our Whisper directly and it'll be ready to go. Let's give that a try. I'm going to clear the terminal window, and I've recalled here the docker run command where we actually mapped the local folder to the one on the container. But we're going to make one change to this. We're actually going to replace the image to use with our image that we just created. So we're going to put in here our Whisper. Now let's hit enter to run this container. And we run a container based on our new image, and let's see if Whisper is installed. Looks like Whisper is installed. Very good. Let's go to the shared folder, and we see in there we have a bunch of the same files as we did before. So I'm going to run the same OpenAI Whisper command, but let's do it with test audio clip 2. So we're now going to transcribe test audio clip 2, but watch how fast it goes compared to before, because it doesn't have to download the model because this image is already prepared with that small model. And there we go. It's run and it's transcribed those files. And if we actually do an ls, or I'll do an ls-la, and we can see there are the transcription files for test audio clip 2. Okay, let's take this to another level and remove some more steps. Let's recall the command that we just ran, the Whisper command right here. Let's grab this and put it on the clipboard. Now I'm going to hit Control-C because we don't want to enter the command, and I'm going to type in exit. Now we're back at the host. The container is no longer running. If I type in docker container ls, we see nothing is running. Okay, so I'm going to recall the previous command that we just ran. So this is the docker run command that we just ran, but what I'm going to do is, rather than leave it with just the our Whisper at the end, I'm actually going to paste in the command that we want it to run. So basically, this docker command is going to run a new container based on the our Whisper image that we've created. Once it runs the container, it's going to run this command whisper so-and-so, so-and-so to do the transcription. Since we've already transcribed files 1 and 2, let's change this to file 3. What we're expecting to see is something similar to the last run. It's going to go relatively quickly because it already has the small model, but instead of us having to type in a command, it's just going to run the command for us and exit. Let's run it. So I'm going to hit enter. It is starting the container. It's doing the transcription. And there it is. This is clip number 3. And as you can see, it's finished. But not only that, if I do ls-la, you can actually see in this folder, there are the transcription files for clip 3. So what we've effectively done is we've started with the base ROCm image. We prepped it for OpenAI Whisper. We then saved our own image based on that prepping. And then we got to a point here where we can now run that new image that we saved. It will create a new container and run a command for us. As part of that transcription, it will process a file in the shared directory, and it will put the completed transcription files in that same directory and then exit. Since we use the RM switch on the Docker command, it also deletes that container. Now keep in mind, it deletes the container, which is sort of a temporary instantiation of the image. The our Whisper image is still there. You can kind of think of it sort of like C++, where images are kind of like the class and containers are like object instances. So you can run an image to instantiate an instance of the image as a container. But what's nifty about this is we were able to run everything in this isolated environment, including an environment that has all the ROCm installation bits. We didn't have to install anything locally on the system for ROCm. It's all in the container. We run the container in a manner where it can access the GPU as needed. Those are using the switches that AMD gives us on their website. It then processes everything, and we're kind of using this shared folder as sort of IPC, if you will, or a way of sharing data. We're putting the files we want transcribed there, and the container itself is getting the files from there to transcribe them, and it's putting the output in that same directory and then exiting. So in a sense, we've kind of created like a command line utility that will run OpenAI Whisper in a container, process everything, and then exit out, and the results or the output of the command will be right there in the shared folder. All right, let's take this to another level. I have a directory here under the demo directory, so we have \demo that we've been using. Then underneath that, I have test audio clips -multi directory. Now, there's nothing fancy about this. I've just duplicated those test audio clips. But what I've done is I've created different folders. So we have folder 1 with test audio clip 1, but I've given it a different name called folder 1 -test audio clip 1. And if we go up here to folder 2A and then go inside of 2B, we can see here's folder 2A-2B test audio clip 2. And then let's go back up to the top and go into folder 3, and we can see here's folder 3 test audio clip 3. And then we have the same clips duplicated here at the root test audio clip 1, 2, and 3, which is similar to what we had before. So the scenario is you have this folder that has a bunch of media files, and you want to transcribe all those media files in one shot using a script. Okay, well, let's look at this bash script here, and you can find this on the GitHub. So basically, this bash script will look for these extensions within a root folder that is specified on the command line. So in the first parameter, $1, you'll specify a root directory, and then it will go search for these extensions. And if it finds these extensions, it's going to run our Docker container, our Whisper, to transcribe that particular media file. Now, if you don't understand bash, don't worry. I'm going to explain this in layperson's terms, and you can actually go over this later if you want to learn about bash scripting. You don't really need to learn about this in order to, use the script and to kind of experience the tutorial. So $1 is just the first parameter that's specified on the command line, and that's being assigned to root dir. If there was nothing specified in that parameter, then it's going to output some help and exit back to the command line. We're going to skip over this trap thing. You can read it. It's a bash thing that's going to execute if the script is Control-C or exited abnormally. And then it's going to run the Linux find command, and it's going to start from that root directory that was specified, and it's going to look for all files. And then it's going to apply a regular expression, extensions regex, and we're not going to get into regular expressions, but basically it's this string here, and this string is just something that's being built off of these extensions in order to create a special search string that's be able to identify any files that end with those extensions. So in a sense, the way you can look at this line here is search in the root directory for any files that end in those extensions and go ahead and process those in this loop here. So this loop here is going to go file for each file that it finds, and it's going to run these commands here. These commands set up some variables, this outputs some information, and then this is the main line we're going to focus on. This is our Docker command. This Docker command is going to run a new container that it creates based off the image that we specify. The image that we specify is our Whisper, which is located here. We'll come back to this in a second. So it's going to run the new container, but it's running it with --rm, which means remove this container. I mean, get rid of it, delete it when we're done with it. When it runs and creates this new container, it's going to set an environment variable called Python buffered = 1. This basically allows the command output to be seen right away in real time when we're looking at it in the console instead of it being buffered. All of these switches between here are things that came from either the AMD website or the Docker Hub website that describes how to run this container. And I'm basically just specifying some options here that work for my system. I've actually tweaked this to use shared memory 16. I actually think even if you don't have this, it might adjust things accordingly, like it won't use this. But you could technically actually lower this to something if you see some issue. It's then going to set up a shared volume, or really like a shared folder, and and it's going to use the current directory where this media file is located. So host dir name right here is calculated up here, and it's really just the directory of the file name. So wherever we find an audio file like test audio clip 1, wherever that directory is located, that will be set to host dir name. So essentially we're just setting a variable there, and then we're just using that as part of this switch down here. And we're saying map that directory to the /share directory in the container once the container runs. So what is happening here is every time this container is run for a particular media file, the container will run and the shared folder off the root will be mapped to the same directory where the media file is located on the local system. And the next item here specifies our image name, our Whisper. And then the remainder of this line is our command line here. So in this particular case, I'm saying that the English is the language. I'm specifying the output folder as shared. I have a -f option here. Now I don't need that, but I'm specifying -f to tell Whisper to only create those SRT files. So it doesn't create every single file, just the SRT file. I'm telling it to use the small model. Now we know that our image includes the small model already. So when we specify this here, it's going to use the small model, and that will have already been downloaded. And then the last thing here is container file name. Now container file name is basically the media file name, and it's going to be located relative to the container's viewpoint of things off the shared directory, but it's going to have the same name as the media file itself. So for example, test audio clip 1.mp4 is going to be named test audio clip mp4, but it's going to be in the shared directory from the container's viewpoint. And keep in mind, we're running this Whisper command in the container. So this is basically the path to the media file from that container perspective. And it will keep doing that until all the media files are processed, and then it will exit out. Let's give this thing a run. So I'm going to go to the terminal window, and /scripts is where that's located, and it's run Whisper, and we want it to use the test audio clips multi-directory as the root. And we can go get the folder view here so we can see what it has translated when it's finished. We can also do that from the command line. We'll do it from both perspectives. So let's go to the terminal window. Let's hit enter, and it's off to the races. It's processing the first file, and that's the one that's in folder 1. So let's go to folder 1, and we can see there's the output there already. And if we go back here to the terminal window, we can see it's already on clip number 2, and it's just going through each of the clips that it finds. And there we go. Let's look here. We can see that all of these have been transcribed. And this has been transcribed, and we can actually open VS Code. So here we are in VS Code, and we can look at all these transcription files, and you can kind of see they've all been transcribed. So it's kind of nifty. You get to use a container, you share some space with that container. Container processes some work based on what you put in that shared area, that folder. It puts the results there. And not only that, when we invoke the container, we can change what that maps to on the local system. So as we find files, we can say, well, this is the directory that we want to share. And so the file is all there ready to go in the same place for that Whisper command. All right, that concludes working here on Linux with a container, with ROCm and OpenAI Whisper. I'm going to install VS Code. Now that's optional. If you already have an editor that you use, or you want to use VI, that's fine. We just might have to look at some text files and some scripts in this video. And to the extent we have to do that, you'll need some sort of text editor if you want to follow along. All right, so let's say VS Code, Linux, and then we can just click here and then go to the download page. I'm going to download the deb file. I'm going to open up a terminal window and just kind of go to download here. And I'm just going to do apt install and then the deb file. Oops, let's do sudo on that. Okay, I've changed the desktop here so the GNOME dock is there. It was actually on the other display. So if you see the display is changed, that's why. Okay, despite this error down here, if I type the super key on Ubuntu here and type in code, we'll see that VS Code is installed and it does start up. And again, you can use a VI. In fact, I might use VI. I'm just installing this because I like to have it available as part of the demonstration, in case I need it. All right, so we'll close this down. I'm going to actually clear the window here and go back to home directory. Next, we're going to install ROCm and Pytorch directly, natively on this Ubuntu 2204.3 system here. So the first thing we're going to do is search for AMD ROCm install, and it should bring up, okay, so there's curated results here at the top of the search results. Regardless of the search engine, I tend to ignore these curated results unless I see something that's definitively relevant. I just go to the normal top search result. Down here you can see ROCm installation Linux, so I click on that. Now we end up here at this quick install guide. Now the first thing I do is I scroll down here and I make sure that I'm on the latest documentation, so I click latest. And the latest for me is 6.0.2, and now that I know that I'm on the latest documentation, I'm here at this quick start install guide. So what I do is I go and look on here for the package manager option here, which is right here, and I click on that. Once I'm here at this package manager, installation via native package manager, I then click on Ubuntu, and that brings me to the preparatory steps for using the package manager avenue of installation. So what I do here is I grab the steps to set up the GPG key, as well as the steps to set up the repositories to use. After doing that, I'll go back to that one big copy paste and I'll use that. So let's do that. So I'm going to go back up here to the top of this page, and I'm going to click here to copy and paste this to add this these GPG keys, and I'm going to do okay, good. We got the GPG keys installed. Now let's go down here and get the repository for the driver. I'm going to paste that in here. And great, we got the repository set up. And now you'll see that there's one more here for the ROCm repository. So we're going to get that. We're going to put that in here. Good, it looks like we've set up the 2 repositories. And if you're like me and you like to sanity check things, you can just do ls, etc., apt, sources.list.d, and just hit enter. And when you hit enter here, you should see the AMD GPU.list, and you should see the ROCm.list. Okay, let's go back over here to the steps. Now, I'm not going to go here and do these steps after setting up the GPG key. So up here above here is the GPG key and the 2 repository steps that we just took to set up the repositories. After setting those up, I'm not going to do the steps that are after the installation and all this, because those are in the single copy paste. So I'm going to go back up here to the left side pane and click quick start install guide. That's where we landed initially. Come back here and I'm going to click on Ubuntu again, and that brings me down to the single copy paste. I'm going to click here to grab the entire single copy paste, and I'm going to go over to the terminal window and I'm going to paste that thing in there. And it's going to go and be busy for a while installing things. It may prompt me along the way here to accept some things, and I'll just say yes. And it's going to take a little bit because it's going to have to do some builds and things like that as it preps things to install the driver and whatnot. I'm going to hit enter here and continue forward. Okay, there we go. I've cleared the terminal window, and I'm going to go back over here to the installation steps. So I'm going to click over here in the left pane on Install Pytorch. I'm going to click on Install using a Wheels package. But instead of following the steps in here, I'm actually going to look at this sentence right here where it has a link to access the feature, go to pytorch.org, get started locally, and I'm going to click that link. Now, if you scroll down here, you can see there are some options here to select various things regarding your setup, and then it'll give you the command line to enter. Now, if you go and search directly and just say install Pytorch and hit enter, and you can say start locally, and you'll get to the same page. From this page, we're going to keep stable 220 selected, Linux, pip, Python, and then I'm going to select ROCm 5.7, and I'm going to copy and paste this command line right here. Bring this over to the same terminal window. I've actually cleared this window. This is the one that we used before. I'm going to paste this right in here and hit enter. All right, there we go. Pytorch should be installed. All right, with installation finished, I'm going to reboot the system and we're going to test it out. All right, the system's been rebooted. I'm now going to run this small little script here to test to see if the GPU acceleration is accessible to Pytorch. And it says true, so it looks like we're good to go. So the last thing is we want to install Whisper. So let's do sudo apt update. Let's do pip install OpenAI Whisper. Okay, so we have ROCm, Pytorch, and OpenAI Whisper installed natively directly on this Ubuntu 22.04 system. Let's make sure it's working here. We can just do a help. Oh, that's terrific. Okay, great. So it's installed. So now let's go to the demo folder where the test audio clips are. Here are the audio clips. So let's just give it a shot on the first audio clip. We'll let it actually auto detect the language, so I won't even specify the language, and I'm just going to type in the clip name here, and let's let it do its thing. Okay, so it's downloading the, I think it's the small model by default. And we can see it detected the language just fine. And it's also telling us we can specify it in the future to avoid what could be up to 30 seconds for it to auto-detect and figure things out. So in the future, we could actually just say, for example, -- language, space, and then English. And there we go. It pretty much does the same translation. Now let's do an ls here to see what that creates. And we can see it creates various different files. Now each of these files has a format that's kind of well known. Text is kind of the simplest, right? So if we look at test audio clip 1.txt, .text, we can see that's just a text output of what we saw out here on the console, except for, of course, the time values. If we look at one of the other ones, for example, the SRT, we can see that that actually includes some time values here. Okay, let's type in Whisper, and then language equals English, and then let's just do all of them at once. And you can see it worked on clip number 1, it worked on clip number 2, and then it worked on clip number 3 all at once. And there we go. Now, if you have audio that might have some noise in the background in between talking and things like that, they have a lot of different options that allow you to tweak how to deal with certain things. Those get quite nuanced, and it's beyond the scope of this particular tutorial. At this time, we're just going to leave this kind of simple like this. So for this particular insert, I want to compare GPU acceleration versus CPU acceleration. So I'm currently on a system that has a Ryzen 5800X CPU along with a W6800 Pro Graphics GPU from AMD as well. I want to compare OpenAI Whisper CPU transcription with OpenAI Whisper GPU accelerated transcription. So this is currently a native installation. It is not virtualized. There's no container right now at this point running. And I'm going to run this Python command to check to see if GPU acceleration is available to Pytorch. Let me hit enter. And we can see it returns true, which means on this AMD system, we have ROCm installed natively, and we also have Pytorch that works with ROCm installed natively. And this system is Ubuntu 22.04 LTS. Okay, I've cleared the terminal window. We have a time command in here. I'm going to go over this really quickly. So this is the Linux time command, and it's going to time how long it takes to run the command that I have between these parentheses. I have Python buffered equals 1 here, which will effectively disable buffering for this Python program, the Whisper command that I'm about to run. This will allow us to see the output of that command during the transcription process. And the performance impact will be negligible, so we're not really concerned about that here. So it's just nice to be able to see that transcription while it's making progress. And it's also consistent with some of the other commands that I've run within this video. We then run the Whisper command, and I have the fp16 equals false option. That's also consistent with the other commands I've run. So I'm keeping it here to disable any warnings about fp16. The language is English, and I know that this clip contains English, and I really don't want to incur any performance penalty based on figuring out the language. So for a performance test, I feel it's really good unless I'm trying to measure how long it takes to figure out the language. I would rather just tell it what the language is. And then finally, we have the long audio clip, which is really just a 1-minute audio clip. This is the same long clip we use in other portions of this video. And so this will be consistent as well with those other portions. All right, with this time command set up, let's run the command and see what the results are. And we see it took about 10 seconds to transcribe that 1-minute clip. Okay, let's clear the terminal window. Next, we're going to remove the ROCm version of Pytorch from the system. And then we're going to install a version of Pytorch that is going to use the CPU instead of the GPU. And then we'll run the same time command to see how long it takes when it uses the CPU instead of the GPU. Okay, let's uninstall Pytorch. So I'm going to do a paste of this, and I'm going to pip uninstall Torch, Torch Vision, and Torch Audio. I'm going to hit enter. And you can see it's going to remove the ROCm version of these. And it looks like everything was uninstalled. Okay, I'm going to clear the terminal window. I'm going to start up a browser. I'm going to search for Pytorch install. And I'm going to click on this top link that says start locally. I'm going to scroll down here, and we're going to leave stable 2.20 selected. I'm going to keep Linux selected. I'm going to keep Python pip selected. I'm going to keep Python selected. Now, here are choices for the compute platform, and we see there's CUDA, there's ROCm. That's what we just uninstalled. So I'm going to select CPU, and I'm going to select all of the commands down here on the bottom row of this table, and I'm going to right click and do copy. I'm going to go back to the terminal window in the demo directory, and I'm going to right click and paste this command in here, and we're going to install all these for CPU. I'm going to hit enter, and it's going to start installing. Okay, great. It's installed the CPU version of Pytorch. I'm going to clear the terminal window. Okay, so with the ROCm version of Pytorch removed and the CPU of Pytorch now installed, let's run the CUDA check to see if it returns true or false. We're hoping it returns false to indicate that there is no GPU acceleration available to Pytorch. I'm going to hit enter, and we get a false. Good, we're ready for our test. I'm going to clear the terminal window. I'm going to recall the same time command. This is the same exact command that we ran before. I'm not going to make any changes, and I'm just going to hit enter. Let's run it and see how it does. Okay, we see it's significantly slower, 28 seconds when we're using CPU. Let's copy paste the time value and put it into the text file. Let's go over here to our text file, and we're going to put here CPU. Going to get rid of that M. So we see that when we use the AMD W6800 GPU on this particular system, it's about 2/3 faster, or about 60% faster than when we use the CPU. Or more plainly, the GPU can transcribe that 1-minute clip in about 10 seconds, whereas the CPU takes about 30 seconds. Now, there's another portion of this video where I do a similar performance test on a 7-year-old laptop. Keep in mind that this system is a very recent, let's say about 2-year-old desktop system. So this system generally is much higher performing than that laptop. So keep that in mind when you look at the performance figures there. You shouldn't really compare the performance figures there with these performance figures here in a direct sense. Maybe you can correlate something by looking at the percentage of improvement. But even there, when you have hardware improvements and stuff, there's not always going to be sort of this direct correlation where, percentages or ratio differences in performance are going to make sense. I expect that the W6800 GPU is far more advanced than the integrated laptop GPU on that 7-year-old laptop. So they're just different things. But in both cases, we saw significant performance improvement when using the GPU for transcription. Okay, that's it for this portion of the video. Let's go on to the next. So these steps are for installing OpenAI Whisper on a system with an NVIDIA GPU. Now the initial steps are pretty much the same OpenAI Whisper installation steps in the other tutorials, but then we're going to add a step to get the right version of Pytorch for the version of CUDA on the system. The first step is to download and install Python. So we're going to go to python.org, click on downloads, click to download the latest version. This is Pi 3.12. I'm going to click to open to install. I'm going to select add python.exe to my path. Now folks may not add Python to the path. I'm doing it for this tutorial because it's very simple. It'll end up on the path. For users that have multiple versions of Python, they'll usually take a different approach. We're not going to discuss that in this video. I'm going to keep this very simple. Click install now. Okay, setup was successful. Let's click close, closing the browser. You can open a terminal window with the Windows key and X, and then select Windows PowerShell. If you're from Linux and you're just trying out a Windows tutorial, the Windows key is the super key. So I'm going to do everything in a folder named demo. First thing I'm going to do is make sure that Python is installed and on the path, and it is 3.12. Very good. Now I'm going to create a Python environment. So to create an environment, I'm going to type in python-mvm space // and I'm going to call this environment Pi 3.12 - Whisper. Now you can call your environment any name that you wish. If you are following along in this tutorial, I just recommend you use this name. Now I'm using // and a name because I want the environment just to be under the demo directory. It just makes it easier for me to clean things up later. So I'm going to hit enter. And we have an environment created. Now, if you're not familiar with a Python environment, it's not a very complex concept. It's basically a way of creating an area on disk by specifying a subdirectory somewhere, where that subdirectory will hold everything that you install while that environment is active. It's a way of creating a separate space where you can do things like test installing things and removing things, or trying out various Python packages. And you can do all that without polluting or messing with the global Python environment. If you install lots of different versions of things and have different tasks you do in Python, you can run into issues if you only have one environment. So if you want to install something that you want to just be generally available in Python without doing anything special, you would generally install it in the global Python environment. Many users, when they're testing things, or even when they want to have something permanently installed, but they want to kind of keep it carved off into a separate environment, they'll create an environment, just as we did here. Okay, with the environment created, I'm going to type the path to the environment. This is Windows. On Windows, when you create an environment, there's a folder called scripts, which is underneath the environment. And within that scripts folder is a script called activate.ps1. And since we're using PowerShell, that's the script that we want to run to activate the environment while we're in PowerShell. So I'm going to run that script and hit enter, and you can see that the name of the environment will now appear here next to the prompt. If I hit the enter key, you can see that the prompt will always have this environment name here, which is a signal to me as a user of this terminal window that the Pi 312 Whisper environment is active. With the Pi 312 environment now active, let's go ahead and install OpenAI Whisper. So the way we do that is we type in pip install OpenAI-Whisper, and then we just press enter. Okay, there we go. OpenAI Whisper is installed. Okay, I've cleared the terminal window. Let's do a quick test to see if Whisper is installed. So I'm going to type in Wisp and hit tab, and yeah, it auto completes. Let's just type in --help. And we see the help is output, so it looks like it's installed. Okay, I'm going to clear the terminal window. And as part of the whole flow of steps here, I want to run a quick test to show you something in connection with something I'm going to show you again later. Forgive me, I realize this terminal window has got some small text. I'm going to expand this now. Forgive me that I didn't do this a little bit earlier here. Okay, I've enlarged the font here, so hopefully you can see it a little bit more clearly. I'm going to run this little Python script here. Now, what this actually does here is it runs Python the interpreter, and the -C switch is going to allow us to put into quotes here a small little script that we want the interpreter to run. After it runs the script, it will exit. What we're asking it to do is to import the Pytorch package, and then we're asking the Pytorch package if CUDA is available. So let's hit enter, and we see that false is returned, which indicates that there is no GPU acceleration that's accessible to Pytorch on this NVIDIA system. Okay, we're going to run a quick transcription test to see if Whisper is working, and we're also going to time how long it takes. After we capture that baseline, we're then going to activate GPU acceleration on this system, and then we'll check the time of the transcription for this 1-minute clip afterwards to see if there's any difference. Okay, before we capture a baseline, let's just perform the first transcription, because that first transcription is going to incur a penalty of downloading the model, and we don't want the time of downloading the model to be part of our baseline. So we're just going to do an initial transcription here in order to download the model that we're going to use, as well as just simply validate that everything is working okay as is. So I'm going to type in Whisper, and then I'm going to hit tab, space, --language equals English. Now I know the captured audio is English, and I know that I don't have to specify the language because OpenAI Whisper will figure it out automatically, but it takes time for OpenAI Whisper to do that. And so they give you an option where you can specify --language equals English, or whatever the language happens to be. And that's your way of telling OpenAI Whisper what language to use, and then it won't need to spend time figuring out the language, which will save time, and the overall transcription will go faster. So when you know the language that you're transcribing, it's probably a good idea to specify the language parameter. All right, with the language specified, I know my audio clips are in this test audio clips folder, and I have several audio clips, but the one that I want to use is the test audio clip 4-long.mp4. That's about a 1-minute long clip, and it's the one that I consider to be long for all the clips that we have in this video. So let's hit enter to begin the transcription process. Now you can see that OpenAI is going to get the model. And you can see that the model is about 0.5 GB. And there we go. The clip has been transcribed, as you can see. And that transcription process actually outputs a number of files, as you can see here. You've got a text file and an SRT file and so forth. If we look at let's say the text file, it's just a plain old text file. If we look at the SRT file, we can see this file might be more useful to somebody who wants to know the points in time within the source clip where the transcription came from. So the transcription process is broken down into parts, and each of those parts has an index number here as well as a timestamp. And there are other files, as you see here, and you can kind of look at those on your own to see which one might suit your needs the most. Okay, the terminal window has been cleared. Now let's use PowerShell Measure-Command to measure the performance of the same transcription. Because this will be the second time we'll be running that same command, the transcription will be performed without needing to download the model. By the way, we didn't specify the model switch on the command line. You can specify the model that you want to use. We're not going to get into that in this portion of the video. For now, we're just going to use the default model that it downloads. Okay, here is the measure command. Here we're setting an environment variable called Python buffered to the value of 1. When it's set to this value, the output from the OpenAI Whisper Python command will not be buffered and will be output immediately. This will let us see the transcription output as it's occurring. We're then going to use PowerShell Measure-Command, and we're going to assign the result of Measure-Command to this variable mcResult. Now, we're passing a parameter to Measure-Command, which is a script block. A PowerShell script block begins with a curly brace, and it ends with a curly brace. We put in the script block whatever code whose duration we want to measure. In this case, we're putting in the script block pretty much the same Whisper command that we had put before. There are some slight differences. Let me go over those. First, we have whisper.exe. That's the same. I added this fp16 equals false. If you saw when I ran the command before, it had a little warning that it was going to use fp32. If we just put the fp16 equals false switch, we won't see that warning. We have the same language switch here for English. I have the same input file, which is this MP4 video file, which OpenAI extracts the audio from and then transcribes it. It's the same thing we did before. And then we will pipe the output during the transcription to the console by using PowerShell write host. And that concludes our script block. We then put a semicolon to separate that command from the next command. Here we're basically instructing PowerShell to output the runtime of this command in seconds. And total seconds will include not only the number of seconds, but fractional seconds as well. Okay, great. Let's run this command. All right, terrific. It finished, and it took about 93 seconds, 94 seconds if you round up. Okay, I've opened up a copy of Notepad so I can take this value here and right-click to copy it to the clipboard, and then I'm going to hit Control-V in Notepad to paste it in there so that we have a copy of this initial time. And I'll actually prefix this with CPU. Okay, so using the CPU to transcribe the file, it took about 1.5 minutes or about 94 seconds. Okay, I'm going to clear the terminal window. Okay, the terminal window is cleared. Now what we want to do is we want to install a copy of Pytorch that will work with CUDA that is available on this NVIDIA GPU system. On this system, I know that there's a command called NVIDIA SMI or NVIDIA-SMI.exe, and I found that by typing in nvid and tab. After typing that in, I'm going to hit the Enter key, and the output of the command includes some configuration information about this particular NVIDIA GPU environment. Included in the output is the CUDA version, which here says 12.4. Okay, terrific. Okay, with the CUDA version known, let's do a web search for Pytorch install locally. And they have this website called Start Locally. So I'm going to click this. And within Start Locally, there's a nifty little chart they have here where you can select what your environment is. I'm going to keep the default here with Stable 2.20, Windows, pip, Python. And this by default has CUDA 11.8. Here's one that says CUDA 12.1. I'm going to go ahead and click on that. And as you can see down here in the last row of this table, it actually includes a command which I can copy to the clipboard. I'm going to go back to the terminal window. So we have a clear terminal window, but also very important is we want to make sure we have a terminal window where our Python environment is active. That's where OpenAI Whisper is installed. That's where the current version of Pytorch is installed. And so we're going to run the command from that website, and it's going to update this environment. So I'm going to right click to paste that command from the Pytorch website into this terminal window. I'm now just going to press enter, and it's going to update the environment with this version of Pytorch. Okay, there we go. It's installed. Now you'll notice if you look carefully at these lines up above here, you can see where it found an existing installation and it uninstalled that existing installation so that it could update it with the newer version that we have asked it to install. So we've effectively upgraded or changed the configuration of our Python environment here to use a different version of Pytorch, one which will hopefully be CUDA aware for this particular NVIDIA GPU environment. I'm going to clear the terminal window. Okay, with the terminal window clear, let's recall that line that allowed us to test the availability of CUDA. So here we have the same Python script which will allow us to check if CUDA is available. Let's run it. And now it returns true, which means that CUDA is available to Pytorch. And this means that anything using Pytorch can take advantage of GPU acceleration on this system. Let's clear the terminal window. Okay, with the terminal window clear, let's run the same measure command that we ran before when the CPU was used for transcription. But now with the new version of Pytorch installed, GPU acceleration will be used. And let's see what kind of improvement we get with GPU acceleration active on this particular system. Okay, this is the same measure command that we ran before. Let's run it and see if the GPU acceleration improves the performance at all. And there we go. It took about 25 seconds, which is significantly faster than 90 seconds. And we can copy and paste this here and go to our notepad with the other figure. And I'm going to put GPU. So it's roughly about 75% faster than just using CPU alone on this particular system. Now, one thing to keep in mind, if you have a system that has Python 3.10 or earlier, and you're trying to do benchmarks between, CPU and GPU, in order to be as fair as possible, I highly recommend you install Python 3.11 or higher, preferably 3.12. That's because Python 3.11 added significant performance improvements when it comes to certain CPU-bound activities. And so you really want to make sure you have those for your benchmark. Unless, of course, you need to target a Python 3.10 environment and you really do need to see those performance figures, of course, then use Python 3.10 or lower or whatever the version is you happen to be using. And one particular test was on Python 3.10, CPU only. And then I installed Python 3.12 and noticed significant performance improvement on the transcription, on the CPU-bound transcription. Just keep that in mind. Okay, that concludes this NVIDIA specific portion of the video. The simple Windows portion of this video, that tutorial has some other commands where I use scripts and whatnot. You're welcome to take those commands and run them in other Windows environments where you're using OpenAI Whisper. I'm not going to repeat those scripts and commands here. It would just be too redundant. But you're welcome to take those scripts, like there's a PowerShell script in that tutorial, which you could run here just as fine as you ran it over there. They are both Windows environments. They are both running PowerShell. This environment happens to be Windows 10. The other one was Windows 11. But everything should run just fine. You should be okay being able to run both of those. But you can run that PowerShell script not only in that tutorial, but you can run it in a different environment as well, such as this one that we set up here. All right, that's it for this portion of the video where we have an NVIDIA system and we download and install the version of Pytorch that works with this particular system to achieve GPU acceleration. All right, well, there we go. Hope you enjoyed this video. Just a little quick overview on how you can do some audio transcription with OpenAI Whisper on both Linux and on Windows. You see a couple different ways you can run OpenAI Whisper, and so if you have some audio files or video that has some audio that you want to transcribe, you can go get OpenAI Whisper and give it a try. All right, everybody, that's it for this video. If you like this video, I hope you'll click like, of course. And if you want to subscribe, I'm not going to say no. Of course, that'd be wonderful. All right, and that's it. Be well, be safe, rock it out as usual. Until the next video. All right, take care. See you later.